Well, hello everyone, and welcome to my presentation today about SE goes digital and the journey towards predictive maintenance. My name is, as Sjö said, Andreas Stjernudde, and I am the digitalization coordinator at SE's Rolling Stock division. And SE has quite the ambitious digitalization program. Our end game or our goal is to be the most digital company in Sweden. And that is a tall order for a railway company, I would say. But I think we can move on to our first slide. What? Okay. Yeah, major malfunction here. Doesn't matter. I would like to start off with why SCA should approach predictive maintenance. And we have heard a lot today that sensors are becoming cheaper, but even as they are becoming cheaper, we have to equip a lot of vehicles with sensors. That means that I have to have a very solid business case if I want to add additional sensors to our assets. And since I don't have a Wonder Woman to protect me from ROE wanting managers, then so the first one here is punctuality, and that is the most important one for us at SCA. And as an industry as a whole, our goal is 95% punctuality. And I don't think that means so much to you, but we have to consider that from an asset point of view. And do you know how much of the delays are because of vehicle malfunctions? And that is a very, very small part, actually. So that means that any improvement that we can make on the vehicle's reliability will not make a huge impact on punctuality, but it will make an impact, and that is very important. The next is availability, and this is a no-brainer perhaps. A train in the depot or workshop doesn't really generate any money for us and just generates costs. And the last one, efficiency, and that is about reducing the need for maintenance, reducing costs associated with our assets, increasing life cycles, and such things that we have talked about a lot today. So this doesn't mean that there aren't other factors to consider for us when we want to do something towards predictive maintenance. But as an example, traffic safety is always prioritized above all else here. So I think I will move on to our next slide, which is again our agenda for today, and I don't think that this is something spectacular for you. I will try to give you a short company history and an explanation of what SCA is, because I believe that there is also a misconception among Swedes what SCA actually is today, and our challenge in regards to predictive maintenance. And then I will move on to a case, some lessons, and some wrap-up. So starting off with our history then, we'll start back here in 1856, where the Swedish State Railway, or Statens Järnvägar, was formed. And this was your typical 19th century railway company that gathered business area after business area and grew out of proportion, perhaps. And as time went on, this blob of a company had poorer and poorer results. So something had to be done right. So in 1998, the infrastructure was separated from SCA and was in turn given to the state agency Banverket, or the Swedish Rail Administration. This meant that everything that was connected to the infrastructure and the land that we operated our trains on was removed from SCA's care and our controls as well. And as time progressed, more and more parts were removed from SCA, like buses, ferries, hotels, and so on. And finally, in 2001, we were completely privatized, and a lot of business areas were removed from SCA. So what is SCA then? And I will start with what is it not. I already told you about the Swedish rail administration, which is today the Swedish traffic administration. And this means that we have no infrastructure and no control over the infrastructure. So we have to apply to allow our trains to go on the railway, as an example. But do we have engineers at SCA? And in the beginning of the privatization, we had a very reduced engineering staff. Most of the engineers went on to a consultancy company that was then named Interfleet, which is now SNC-Lavalin, or a part of SNC-Lavalin. Rather. But maintenance then, surely we would have somebody doing maintenance, and no. Maintenance was removed from SCA, and we now have to buy that from maintenance suppliers. This is one of the companies you remain, but we have other ones as well, like Mantena. But surely depots, I mean the very place where we park our trains, or the platforms where our customers enter our trains, and you guessed it, no, it is also separated. So what do we have? Well, we have a kind of wall of contracts here. So everything that we want to do, we have to do in cooperation with any one of these entities in order to achieve anything. Yeah? So what is SCA? And I would say that SCA is a traffic operating entity. And what that means in layman's terms is that we are train crew and assets. And this causes some problems for us in regards to predictive maintenance. It's the only thing that we really own are the assets. We can't do anything with the maintenance in itself, or we can actually influence some parts, but not the whole part. And we don't have any infrastructure to mount detectors on or do anything else with. So everything that we want to do regarding predictive maintenance needs to be coordinated with other parts. So I'm going to talk to you a bit about our assets, and starting off with all locus and coaches, and their potential for predictive maintenance is quite low. They were constructed from the 40s up until the early 90s. The only thing that we can do with them is pretty much surveillance them from the outside, which is why I have talked about infrastructure monitoring. Next came the X2, and here we have some rudimentary sensors and potential towards predictive maintenance, I would say. And now we're doing a midlife upgrade of the X2, which means that this fleet will probably be the one with the most potential in the future. And then we have our X40, popularly called the double-decker, and the X55, which both provide some limited amount of predictive maintenance potential. But what will happen in the future, and what I can say is that whatever kind of vehicle we want to procure, it will surely have a lot of sensors mounted on it already. So what about the virtual side of it all? Well, yeah, sure. This one is going to say bye-bye. Oh, virtual assets. When I started at SCA, we had an old mainframe system, which had its ups and downs, I would say, but our newest SAP system is supreme in most ways, I would say. But moving on to our darker side, I would say, is that we have had remote diagnostics or sensor data from our assets for quite some time. But we have really failed to utilize it in a really good way. We have failed to implement processes to take care of that data and make some good decisions out of that. So what we're doing is that we have bought a new system that we want to consolidate all of this sensor data into one and complement that with a rules engine in order to create additional potential towards condition-based maintenance and predictive maintenance. So the case then. And now here we're overlooking our Stockholm depot, the largest depot in Northern Europe. And my question is then, where can we as an operator find some money? Where do we save all this money that predictive maintenance is supposed to yield us? And then the only thing that we can attack really at the moment is our assets. And our assets have a lot of systems that have potential. In this case, we could, for example, speak about doors or HVAC or brakes and things like that. But for this case, I will talk about something that's called a bogie. It looks like that. And this thing is the thing that makes the train roll and not derail. And here we have one problem, and that is that we have an overhaul interval at 1.2 million kilometers for the bogie as a whole. But wheel bearings, 0.63 million kilometers. And wheels, 0.8 million kilometers. This means that we have to do overhauls with a very short distance between each other, right? That means that the train will have to be taken out of traffic to do these overhauls. So what if we could change that? Perhaps we could have wheel bearings at 1.2 million kilometers and wheels at 1.2 million kilometers as well. That would greatly improve our availability of our fleet. But these intervals here, 0.8 million kilometers and 0.63 million kilometers, they are based on numbers from people that are way smarter than I am. So how can I approach this problem? Well, the only real thing for us is to do this with condition-based maintenance or condition monitoring. And if I return to my second slide, the things that needs to be there in order to motivate a predictive maintenance case for us, and that is punctuality. Well, if we can reduce failures in wheel bearings and wheels, then we will have less delays. Availability is the whole point of this exercise. And at least efficiency. Well, if we can have all of these maintenance done at once, then we will remove the other intervals and thus make the workshop planning more efficient. So yeah, free for free. We should do this. So we need a solution for wheel bearings, and we'll start there. First, we have one solution that we have mounted on our X2 fleet. And this is a sensor that monitors acceleration and temperatures. And from these graphs of vibration and temperature, an external company can then do some analysis on this and return the data to us. And the data is always owned by SCA. And this particular solution here is, I would say, quite advanced, and we can, from the solution, also get other advantages like wheel damages. We can detect different vibrations than, let's say, a defect wheel bearing. But we also get rail health, and then you would say, why would we need to monitor the rails? The rails are in the care of the Swedish Traffic Agency or the Swedish Rail Agency. And that is true, but as I said before, we are a system, and if one part here fails, then it fails for all of us. If our trains stand on infrastructure, then nobody else can ride the trains. As you might remember from yesterday, where no train was able to go between Stockholm and Gothenburg. And with the solution, we get a 3 months heads up for our wheel bearings. So that's one solution. The other solution is, I would say, a less advanced solution, but not worse. It measures quite infrequently, if that might be a clue. And it measures once per day. And if it detects an anomaly, it increases its measurement intensity. And it also measures the same thing as the other solution, it's temperature and vibrations. And this data is also processed by an external company that then return the results to us. And it has a number of advantages. One is that it is easy to install, but then we don't get these added values like rail health or wheel damages with this version of the product. I must add, a newer version might be able to add these values. And we also get the same 3 months heads up. So then we have condition monitoring on our wheel bearings. So that's one part of our problem here. And the next part, wheels, that is a bit more advanced, and I will try to give you a crash course in wheels. So this is the thing that keeps you from derailing, pretty much. And this part here is the flange, and that is what keeps the train on track. So here you see the wheel bearings, the wheels, the disc brakes, and so on. And connected with this is a lot of measurements. And these measurements are important for different things. One could be equal conicity, or equivalent conicity, sorry. And that is important for comfort for our passengers. But we also have strictly regulated demands on what kind of profiles we can run our trains with. As an example, the flange height, the flange width, and the flange slope. So if we exceed any one of those limits, then we can't traffic our trains. And then there's another issue with traveling internationally, because Norway has other demands than Sweden. So we might have the problem that we take a train, go to Norway, and then we can't take it back. So that is the introduction to wheels. So now I will start to talk about these profile dimensions, and here you see measurements taken at different points at the wheel profile. And as you can see here, the values degraded over time, and then you have an increase, and that is because you either have a overhaul or you are forced to do a lading operation. And on the other side here, you see the same kind of measurements, but as a profile. So here you can see how the measurements deteriorate over time. So then we have the wheel profile, and then we should be golden, right? No. We have another issue, and that is wheel damages. I don't know if you can see it. Well, so, and as you can see, there's a small flat there. And this one causes damages to the wheels and the infrastructure as a whole, and also causes discomfort and so on. And this is something that we have to remedy when we detect it. Another issue is cavities, and these don't really cause a lot of problems at the beginning, but as time progresses and they become deeper, they cause problems. And another problem here is that when you allow these cavities to get deeper and deeper, you have to machine away a lot of material, which greatly reduces the life cycle of the wheels. So how do we approach remedying this then? Well, one solution is to use a so-called thread dilation sensor. And that is an infrastructure-mounted sensor that detects increasing forces on the rail. So here on the left side, you see a healthy wheel. And you might note that the scales here are different. And here on the right side, you have a damaged wheel. So here you can probably see that it is a wheel flat, but yeah, it's not important. So anyway, now we have condition-based data for our wheels and our wheel bearings, and that should be good. But have we made any money now when we have condition-based data, or we can have condition-based maintenance? Well, we could, but we might cause additional problems. An example being that we might take vehicles out of traffic at the wrong time, causing problems with workshops or passenger occupancy. So we have to also consider these other factors. Example, when would it be most beneficial to take this vehicle out of traffic? When do we have the least amount of passenger occupancy? Can the passenger occupancy make the situation deteriorate further? And then we have the workshop plan to consider, not only for capacity, but also for other maintenance plans. And I think then when you have combined all these data and perhaps some more sources, then you end up with predictive maintenance. So my lessons for you today is to have a structure. Go about a predictive maintenance project in a structured way. Do not just select a sensor out of the catalog and say, hey, let's do this, but approach it differently. And you don't really have to keep your data to yourself. Sometimes it can be very beneficial to share your data with other ones that are close to your business area, unless you're competitors, of course. So I've been speaking about a structure here, and I suggest that you start with the purpose of why should you do this predictive maintenance project. Is it to improve reliability, availability, safety, efficiency, so on? And then you need to have goals for this. This is to remove manual inspections, or what is it that you really want to achieve in order to measure it properly in the end? Which brings us to methods. How do you want to approach this kind of project? Do you need additional sensors? Do you need to retrofit? Do you need detectors, or is the data already available to you, and the only thing you need to do is have additional resources that can do something with that data? And last but not least, processes. And here's the part there where SA has failed before, I would say. You always have to change your processes in order to make room for the new technology and not adapt the new technology to your organization, I would say. So always consider education and how this will affect your operations. And I would say that you should also have a systems perspective when approaching an issue of this magnitude. As an example, I could talk about the wheel profiling. Some people at SAS say to me, well, we should only get the wheel profile, then we don't have to do manual measurements. And yeah, that is true. We wouldn't have to do manual measurements, but we would still have to look for the wheel damages, and thus we don't really improve anything. So always consider what synergies could be gained by doing something else. And punctual as a train operator, I am now done. So thank you.
Thank you.